Hi, my name is Doug Black. I'm editor-in-chief at Inside HPC. And today we're talking with four HPC industry experts about trends, discussion points, and presentations coming up at Virtual SC20 next week that they think might be particularly interesting and worth your time. Before we begin, I'd like to thank our sponsors for this panel, Supermicro and Intel, for supporting this discussion. Our panelists were selected because they have varied HPC interests, areas of expertise. So we hope to provide a broad perspective on next week's conference. We have today Steve Conway. He is Senior Advisor, HPC Market Dynamics at industry analyst firm Hyperion Research. Next, we have Addison Snell. He is CEO of industry analyst firm Intersect360 Research. We have Elod Raz, CEO of stealth startup NextSilicon, which is developing a new approach to HPC architecture. And finally, we have Dr. Thomas Sterling. He is a veteran supercomputing writer and teacher. He's professor of electrical engineering at Indiana University, who also did pioneering work in HPC cluster computing. And he is president and chief scientist at Simultac LLC. So Steve, let's start with you. I understand that a theme you'll be looking for next week is around the movement toward more balanced systems architectures.
Yeah, as you all know, the architectures over the past decades have kind of drifted toward extreme compute centrism and not so friendly toward data. And with the rise of AI and other data intensive methods, particularly, the next generation architectures, exascale and so forth, are trying not to fix that right away, but to alleviate that imbalance. It helps very much that programs around the world, US, Europe, Asia, are no longer as focused on LinPack machines as they used to be. And so I'm looking forward very much to see what progress is being made there on the architecture side to support a mix of simulation and analytics. And on Tuesday, there's a post-von Neumann architecture session that looks very interesting.
Next, we have Addison Snell at Intersect360 Research. Addison, I know that you'll be looking at issues around growth and the impact of HPC in the cloud.
This is something that Intersect360 Research and Hyperion Research have both been talking about, particularly, as Steve was pointing out, with some of these data-intensive workloads and AI. A lot of those have a great deal of cloud affinity. And something that we've been talking about is that the impact, the total impact of cloud in high-performance computing goes beyond what gets directly measured in a cloud portion of the budget. We survey end users on how their budgets get divided between hardware, software, services, cloud, etc. And in our pre-SC20 webinar, which is now in the presentations tab of our Intersect360 Research website, we described how different segments additionally complement the HPC cloud number, where what we found is, starting in 2019, we increasingly found additional cloud contribution out of, for example, the services budget, the software budget. If people had managed services contracts or SaaS types of contracts that weren't in the budget under cloud, but were nevertheless leveraging cloud in terms of the fulfillment of that portion of the value stream or their workload, that was an additional contribution of cloud. And as Steve was setting up, these data intensive workloads, I think, are helping to contribute to that as a very high growth portion of the HPC environment right now.
Now we have Thomas Sterling at Indiana University. Thomas, what topics will you be looking for at the conference next week?
My driving interest would be in the area of both the driving impact that we know HPC has had to have, frankly, in very important, very difficult year, at the end of Moore's law, forgive the cliche, what indications are there of how architecture may be moving forward? And I'm interested to understand how it will both change but retain value for the end users. And finally, I'm just looking for new ideas. I always enjoy seeing things I'm just not anticipating. So that would be my on the floor, albeit now virtual.
Next, we have Elod Raz, CEO of NextSilicon. Elod, knowing your company is working on a new HPC architecture, share with us your thoughts about SC20 and discussions around alternatives in HPC beyond the current rise of CPU, GPU integration.
Thank you very much. I would like to add to Steve and Thomas' answers. And one of the things that attribute the HPC world is that the HPC adopt leading edge technologies. We have seen that the HPC started, SGI started using GPUs back in 2009. And probably the new innovation will come from the HPC market. And only time, and Thomas said about the cliche, only time will tell whether Moore's law will eventually die. And we are seeing a lot of new architecture that utilize memory technology, cache coherency, new instruction like vector instruction set, SIMD, and matrix multiplication. But all of those introduce trade-off between peak performance and programmability. Writing a software algorithm, a C code for those architecture is easy. Writing the program that will utilize those peak performance is a whole different story. And I believe that the future of the technology is the one that is easy to program, and future architecture should focus and let the scientists focus on science and not be a vendor lock. And there is an interesting discussion about the future of post-Moore's law that I'm going to tune in.
Okay, thanks. Steve, coming back to you, I understand you'll be interested in themes of AI hype, giving way to issues around trust, and overcoming other AI challenges.
Yeah, AI is moving forward, and I'm happy to say, and I guess, rest in peace, Stephen Hawking would be happy to know that the issues of ethics, legal liability, and trust are getting addressed, and only for practical reasons, because things couldn't move forward very well without that happening. So it's really great, but we're not there yet. Deep learning is still pretty much opaque. That can't continue. And data is scarce for a lot of, especially deep learning, which is data hungry. And so what I'm very interested in is these methods for creating synthetic data in high volume that's indistinguishable after a while from real world data, and usually through adversarial networks methods and so forth. That's got to happen, because particularly in some of these use cases like precision medicine and so forth, the data available that's useful is minuscule compared to what's really needed to move this stuff forward. The one other thing that's really important, and it's very encouraging, is so much has focused on training, but now in the last year or so, inferencing is getting more attention. That's where much of the intelligence of artificial intelligence lies. And so that's got to be quite a bit improved. We need bigger brains to do, tougher kinds of AI problems.
Thanks, Steve. Addison, I understand you're also interested in developments around HPC processor integration and on high performance interconnects. Share with us your thoughts in those areas, please.
Yeah, thanks, Doug. And with regard to the processors in particular, a lot of this has been accelerated by these trends around AI, machine learning in particular, and where machine learning and HPC have the greatest overlap or the greatest affinity is on that training side. We've already been monitoring for more than 10 years the incorporation of GPUs as a predominant form of accelerator in high performance computing, and these changes in the dynamics of the supply around processor technologies has really been one of the dominant technology discussions in high performance computing. And that's at a new inflection point now, because we're seeing consolidation, not only literal consolidation with things like the proposed acquisition of ARM by NVIDIA, but just the technological consolidation between CPUs and GPUs, where NVIDIA, who's been the dominant GPU provider, is now going to also have CPUs in addition to interconnects, but they'll have the CPUs with ARM. AMD, of course, has its own GPU, the Instinct GPUs, together with the EPYC CPUs. Intel has its own pending Intel Xe GPU alongside the Intel Xeon CPUs. So the future seems to be trending toward these integrated solutions from single vendors for the high volume portion of the market. And this is going to be a very interesting dynamic to watch, because according to our end user research, what people are the most comfortable with, the most experience with, and even want to see in the future, is the x86 CPUs, either with Intel Xeon or AMD EPYC, together with the NVIDIA GPUs, which are currently on the A100, and there will be future generations there as well. And if we look at how much experience, or even what the future outlook people have for the other elements, the Intel GPUs, the AMD GPUs, the ARM CPUs, that's a lot further back. So to what extent we'll see a developing ecosystem around these areas that people do have less experience with, and is it going to remain an open ecosystem where I pick and choose, or do we start to see it consolidating around all AMD, all Intel, all NVIDIA? Is going to be a dynamic we're going to continue to watch. Now, to Elad's point, there's a lot more beyond just CPU and GPU, and we've seen FPGAs out there along with other custom silicon projects. We have these large wafer scale things that are out there. And I think if it does consolidate around these all Intel, all AMD, all NVIDIA packages, what that does is it opens up the dynamic for additional solutions that are specialized in other areas that aren't that maybe aren't perceived as being well served by these integrated solutions elsewhere. So that's a long answer for saying that really the dynamics in the processor space are getting no less interesting this year going forward, and that's a big part of what we're going to continue to track at supercomputing and in our research next year.
Thanks, Addison. Over to you, Thomas. What conference highlights do you think stand out that are of particular interest in which you plan to participate?
Yeah, so one thing I would say as a quick overview is that I consider the program for SC20 to be as diverse and as rich as the prior conferences that we've had the pleasure of attending. I was at the 1988 first conference in Orlando when Seymour Craig gave the keynote address. While I haven't been to all of them, I have certainly considered as a key point in any year. I picked out just a couple of things I'd like to bring to everyone's attention, maybe no surprises. The first is I was very pleased to see what the keynote address is. The keynote address is being given by Bjorn Stevens at the Max Planck Institute of Meteorology. Its title, let me read this, is From Deep Thoughts to Destination Earth, Climate Science in the Age of Exascale. Now, this is really important because one of the major concerns in which HPC contributes is in understanding climate, the evolution of climate under the extreme conditions, and also appreciates the importance of macro phenomena, tornadoes, hurricanes, I'm supposed to be able to say cyclones and tsunami. Anyway, the major parts all work together, and in the short term, the effect of climate on the weather patterns that we're seeing, which are really 2 to 3 sigmas out, at least in the U.S. I think this is a really good keynote address. I will be honest, I haven't always thought that the selection of the keynote speaker at SC has been adequately focused on our problem space, but this is a very good one. Then the second thing I'd bring out is a set of invited talks, and this is a friend and colleague, Bill Gropp, along with his colleague, Saf Alam, contributed to putting these together. I won't cite them all. I'd like to mention that there are 4 sessions. I think I got that right. And they are, one of these sessions is on the future of AI and HPC, looking at alternatives, the neuromorphic computing and neural accelerators. Now, this has been a theme that has existed over, at least 7 years, if not more. Well, to the 1980s with a classic neuromorphic computing. But this is a fresh look, and that's very good. Also, the HPC and AI and the iterative of HPC processes. So this merger that we've been watching is continuing to grow, indeed accelerate, and understanding methodologies that will become more commonplace, so that not every practice is a revolution and the user has to relearn it. This is very good. And the last session is about post-Moore's law. And so the two talks, one, Borkar, whom I know well, the future of computing in the so-called, and in quotes, post-Moore's law era, unquote. And the other, also colleague, Tom Conte, is simply HPC after Moore's law. And I'm glad to see that these topics are being refreshed and examined, because we're getting on a steep curve, but understanding that curve is the same. And the I don't mention just briefly that there is a plenary that is a session, I don't know how to describe it, in advanced computing and COVID-19. It's more than HPC. It's being moderated by David Abramson, whom we all know from Australia, and it includes a number of long-term contributors. And this will be a discussion session. Rick Stevens, a friend of mine, will be on that and has a very broad imagination. And finally, I'll just mention that for me personally, I enjoy the bird feather session. And the reason is because of all the parts of the supercomputing conference, frankly, it's the one that has the least regimen, discipline in doing quality stuff, and it allows people to be a little bit more on the fringe and a little bit more themselves. So the looseness, but it also allows new speculative ideas to come up and play, and it provides for a lot of people who frankly wouldn't be included. And just to answer the question that we were talking about, the top 100 supercomputer session will be the first one. This is Eric Stern, Jack Nangara, Simon, and representing Hans Maurer, who sadly is no longer with us, his son Martin Maurer. And this is the top 500 supercomputing. And while I would say we all recognize that LINPACK is not the final representative methodology of determining all of the values and comparative means among machines, nonetheless, after over 2 decades, I hope I'm right, yes, after over 2 decades, maybe approaching 3, we have such a valid technology database that we can continue to appreciate mining. Many other birds with feathers said, I would strongly suggest that your viewers, Doug, go and just take a look at the schedule, and you'll find some that will be interesting.
Thanks. Great stuff, Thomas. Elad, over to you. Share with us some of your thoughts on how the future of HP systems might look.
Yeah. So following up on what Thomas said, I'm also eager and expecting to hear the talk about the future of AI and HPC. So please watch that talk. And when I founded NextSilicon, I put a lot of thought about how systems are being built, what the future system are going to look like, what are the current technology, and what are the next technology will look like. And I came into a conclusion that the future of the next hardware is going to be based on software, period. Compute-intensive application, massively parallel application are measured by throughput and not by latency. And to extend on what Addison said, the next generation HPC system will be a good balance of compute, memory, interconnect, and IOs. But obviously, the emphasis must be on general purpose, easy to program rather than a vendor lock system. I don't foresee having any of a universal processor in the near future. However, I do believe that more and more systems will be heterogeneous and combine CPUs, interconnected spatial accelerator, and we are going to see more and more acquisition and consolidation in the HPC market.
Thank you, Elad. Steve, share with us some of the sessions you think might be of particular interest coming up next week.
One that's very interesting to me is there's a Wednesday workshop called Extreme Scale Programming on Models and Middleware. This is interesting because continue to believe that software advances are going to be more important than hardware progress for the future of HPC. I mean, they'll both be important, but software particularly important now because of the complexity and heterogeneity of the task and so forth. And also because even in AI, the major use cases, it turns out, benefit from concurrent simulation and analytics runs, for example. And right now, the results of those are often orthogonal and have to be combined in the heads of researchers instead of in the computer. I know that people are working on that problem, but it is heavily a software problem. So software, I put a word in for the importance of software as we talk about this.
Thanks, Steve. Addison, I understand you'll be looking at the student cluster competition. What other sessions do you plan to put on your schedule?
The student cluster competition is always a highlight to me, and I'm delighted to see not just student cluster competition, but how robust the student programming is around SC20. This is a critical issue in terms of the long-term development of a workforce for high-performance computing. So I'm pleased to see all of the content there. I like that Thomas brought up Top 500, and I remain very interested in Top 500. I think it's extremely relevant, particularly as we head toward exascale. And we didn't even talk about some of the interconnect dynamics where we've got custom high-end interconnects now, like Tofu from Fujitsu and Slingshot from HPE Cray and BXI from Atos, and the role of those in high-performance computing. So that's something that we'll continue to watch. And I think Top 500 really does continue to be relevant here. Yes, there's a debate with regard to LINPACK, but that's as it ever was in our industry. Every time there's been a generational shift in how computers were built. We talked about this in the transition from vector processors to scalar processors, and from SMPs to clusters, and from single core to multi-core, and CPU only to accelerators. Every one of these, when we've had a new shift in how we build computers, has sparked some debate about how we compare computers in one generation to those in another generation. And that's no different now as we head toward exascale. And therefore, another big thing I'm really looking at is at SC20 is how these ecosystems are developing around some of these new tools. This week, as the tutorials and workshops are starting to kick off. There's a new ARM HPC user group that I think is worth checking out, just in terms of how these ecosystems develop for new categories of computing. There's also, with the virtual format, a chance for me to get involved in more of the panels and other things around the show floor that I often wouldn't have time to take in. I love that Thomas was mentioning the keynote around climate science, as well as the More Than HPC plenary panel for COVID-19, which is hugely important. I'm going to look at some of the other panels. There's one that I'm particularly interested on HPC agility in the age of uncertainty. That's going to be pretty cloud heavy, but to my earlier comments about cloud, I think that's relevant right now. And we haven't even talked about storage at all in this here panel right now. And with everything that's emerging with NVMe and Flash, I actually moderate a panel on the diverse approaches to tiering HPC storage. That is a great panel with a lot of different vendors and different approaches on it. So I would recommend anybody checking that out. And then the final thing I'll say, this is really different with it being a virtual conference. I'm going to really miss the hallway conversations that are normally some of the most important things, or the conversations I wasn't counting on, the chance encounters. It's a community, and it's important for us to spend time together. So I'm going to be looking for some of the discussions after the discussions or after the presentations. What's going on Twitter? What's going on in the HPC huddles? What are some of the other electronic forums, to see how does that community carry forward as best we can in a virtual environment. And I'm grateful, Doug, that from your chair at Inside HPC, you're putting together these panels for us to try to enable some of these discussions.
Thanks, Addison. Thomas, what other broad observations do you have about SC20 going forward?
Well, I think this is an inflection point, to use a cliche. It's clear to all of us that we're not only trying to get this job done, but we're really inventing a shared methodology in how to meet and exchange information and ideas, and to some degree to entertain. I have been on more than one virtual conference, and I would say so far this is the most elaborate one planned, and perhaps closer to a complete conference that we can hope to get. It may be that as a result of the COVID-19 pandemic and all the ways that we have been forced, both in SC20 and in many others of our almost daily interactions, that we will devise these technologies and methodologies and our own skills such that this will become more commonplace, reducing of the overheads in doing this. However, Addison made it very clear that there's something about the serendipity of encounters that catalyze new conversations and new even ideas. Things get planned just by accident. I don't know yet how that's going to work, although I know that there are pieces of this, joint rooms and so forth, in which we will try to do it. So I think that by having SC20 and doing it virtually, we're in fact creating a new methodology, a new paradigm for holding full, highly dimensional forms of conferencing. And I think the impact on students may be significantly of value due to the lower costs and so forth, and accessibility of all the different speakers. So I feel like we're part of something new, and I'm looking forward to finding out how well we do and learning how we can do it better.
Thanks, Thomas. Elad, how can the HPC community best make use of AI machine learning hardware solutions?
Absolutely. Well, the entire SC20 is filled with lectures, and I think that Thomas and Addison named all the lectures and sessions about AI and machine learning, so I don't want to repeat. And AI and machine learning is being a buzzword in the industry for the past few years, covered by Intersect and Hyperion and others. AI and machine learning transform our daily life and will continue to do that in the near future. We are seeing a lot of machine learning vendors that designing a complicated accelerator with a lot of matrix multiplication and lots of floating points. And the HPC community tried to modify existing applications and use and utilize those hardware resources to speed them up. However, they often sacrifice accuracy and working in a low precision to get some throughput. Now, other researchers in machine learning are trying to use the nature of those algorithms, which give you a prediction on a data set, and try to reduce the number of calculations for complex simulations, such as weather and hydrodynamic simulation. But it's yet unknown whether those approximations can literally reduce the number of calculation needed. So I'm eager to hear what the community has to say about it.
And staying with you, Elad, you've identified some presentations next week you think will be of interest. Could you share those with us, please?
Yes, I'm looking for the future of AI and HPC by Catherine, and the future of computing in so-called post-Moore's law area. Again, Moore's law didn't die just yet. And there are many lectures. Rick Stevens is giving a keynote about AI machine learning that I'm tuning in for.
Oh, okay, Elad, great stuff. Thanks so much. And I'd also like to thank all of our panelists for their participation today. We hope this gives you some good guidance on how to spend your time at Virtual SC20 next week. I'd also like to thank our sponsors, Supermicro and Intel. Have a great SC20. Powered by Supermicro and Intel. Learn more at supermicro.com.